Hey, I didn't see you there. Today we're going to be speaking about conservation of energy. But before that, we have to go over some important vocabulary. Our first word is work. Work is when a force is applied to an object and moves an object measured in joules. Our second word is potential energy. Potential energy is stored energy of position possessed by an object. Our next word is kinetic energy. Kinetic energy is the energy of motion. Our last term is law of conservation of energy, which states energy cannot be created nor destroyed. It can be transformed from one form into another, but the total amount of energy never changes. In our first demonstration, I'll be showing you how potential energy shows its role in conservation of energy. So here I have a soccer ball and a stress ball. When I drop the soccer ball, it goes up to around knee level. And when I drop the stress ball, it doesn't go up at all. When you drop them individually, each ball starts off with its own potential energy from the height of the drop. Here I'm going to put the stress ball on top of the soccer ball and drop them at the same time. Let's see what happens. As you can see, the stress ball went higher the second time than it did it the first time. When the soccer ball bounces, it compresses, storing potential energy, and as it releases it, it springboards the stress ball upward at the right moment.
I'll be showing you now another example of potential energy and kinetic energy, how they work together. Right now, the ball's at potential energy, and I am going to give it some energy to put it in the energy of position, which is known as potential energy. So once I release the ball, it will now become the energy of motion, known as kinetic energy. Once the ball comes back to potential energy. But let's see if I decide to give the ball a push. The ball came higher this time. The reason for that was you're adding the energy I gave the ball plus the potential energy I already had. Now we're going to see another example of how the law of conservation of energy works. Here we have two wine bottles that are attached to a string. We're going to give this wine bottle some kinetic energy, and let's see what happens. And as you can see, the wine bottle that I gave a little bit of kinetic energy is now transferring its energy to this wine bottle, because the law of conservation of energy states that no energy is ever destroyed or created, but transferred. For our next example, I will show you guys how potential energy and kinetic energy is transferred. So right now our ball is at potential energy and my leg, it's moving, which is at kinetic energy. Once I tap the ball, I transfer my energy from my leg to the ball. That relates to the conservation of energy. And for our last demonstration, I'll show you how the ramp and the Hot Wheel cars relate to potential energy and kinetic energy. Right now the car is at its potential energy, and once I push this button, the potential energy has converted itself into kinetic energy. Now we're going to talk about the formulas that we need to know. The first important formula that we need to know is potential energy, and the equation for that is PE equals M times G times H. And what does each variable stand for? Alright, the M stands for mass, G stands for gravity, which is always 10 meters per second, and the H stands for height. Now let's see an example. Let's say that we have a car that's on top of a hill, and let's say that this car weighs 500 kg, and the height from here to the ground is, let's say, 100 meters. How will we find the potential energy for this car? Alright, so we have the mass, which is 500 kg times the gravity, 10 times 100 meters. Now let's find the potential energy times it. You get 500,000. Remember that potential energy is always in joules. Alright, the second important formula is kinetic energy, and the equation for that is Ke equals 1/2 mv squared. And we know that m stands for mass, and the v stands for velocity. Now let's put this into use. Let's say that we have a vehicle that weighs 30 kg and is above a hill that is 100 meters off the ground. And first, in order to find the kinetic energy right here, we have to find potential energy. And we know the formula for that, which is P.E. mgh. We know the mass is 30 times the gravity is 10 times 100 meters. And when we do this, we get 30,000 joules. And we know that our potential energy is converted into kinetic energy. So we get 30,000 joules that has now become kinetic energy, and our potential energy is now 0. But why this formula? Because we've used this formula to find the velocity that the vehicle was traveling. So let's put this into use. All right. So they give us our kinetic energy is 30,000. It's 1/2. Our mass was 30. And we're looking for velocity. And to do so, we can divide this, which is 30 divided by 2 is 15, b squared, and 30,000. So we divide the 15 to both sides. Cross that. 30,000 divided by 15, we get 2. So you get 2,000 joules equals v squared. Now what we have to do is isolate the v. So we square root it. And to find the square root of 2,000 is simple math, which is 44.72 meters per second. And that's our velocity.
Our third important formula is for work. The equation for work is W equals F times D. F standing for force and D standing for distance. An example would be, say I have a box with the force of 10 newtons and I move it 7 meters. So the equation would be solved by multiplying the force and distance. So we'll be multiplying 10 newtons times 7 meters, equaling 70 joules.